Hello, today we are presenting our lesson 3 of the Universal Programming course, and today we will start with some very practical and very simple examples, and we'll start with the first real-world modeling pattern. As you remember, the first two lessons were devoted to discussing concepts, why we're doing it, what we will be doing, and concepts of what we want to achieve. Today we'll go to very practical, very simple example, and we will increase complexity of the examples as we go. So let's start. So the first example that I want to talk about today is called value translation. As I told you on the first lessons, we will be talking first of all and starting always with discussing the real-world problem that this pattern represents. And what is the real-world problem? What is the example of that? For example, let's say we want to translate a value from distance in kilometers to distance in miles. This real-world problem is presented to us many times. If we want to convert, we want to see what's the distance. We are more used to distance in miles or to distance in kilometers, and it's given to us in a different dimension, different units, so we convert it and then we can compare it, we can feel it. Same thing happens in software. Let's say you have a library which accepts as a parameter, some function in the library, which accepts as a parameter value in kilometers. And we have another library or internal representation of the variable in miles. And we want to convert between those two values. What will be the very simple and very straightforward approach to that problem? Let's say we have a function, and we want to pass there a value in kilometers, but we have a value in miles. So we will pass it distance. Let's say the variable is called distance, and we will divide it by 1.6 and be done with it. Very simple and very elegant, I would say, in quotes, solution. What's bad about it? What's wrong with it? I would say this is solution that works, but it's non-professional solution. Why? What is bad about it? What is bad about it is if you have values in both kilometers and miles in your software, it could be very easy to make a mistake and pass a value in miles where you should put value in kilometers and vice versa. And by the way, there is a very famous software error that caused the crash of a satellite that was based exactly on the same mistake that was done in software. So what can we do about it? What is the solution of this pattern here? So the solution of the pattern is, the direction of the solution is to make our software environment, software language, software framework, whatever, software to automatically detect that the mistake that we are making, desirably, and warn us that it is wrong. How do we do it? We do it by creating special type, two special types. Type 1, that we will call distance in kilometers, and another type, type 2, that we will call distance in miles. And what we will do now is, in every function prototype and in every variable declaration that we will do in our software, instead of using integer as a universal type that you can pass anything to this type, we can use one of those two types to declare variables and to declare parameters. And if you pass the wrong type to this function or to this value, the compiler will warn us, and we will not be able to compile such a program. So it will tell us that we made an error. And that is a solution to this problem. So now we learned how to do a proper typing when you're doing value translation. And in some strongly typed languages like C++ and Java, it is directly supported, and we will show you in special file accompanying our presentation how to do it in concrete languages. Since C is a not strongly typed language, it is much harder to do it in C. So in C, as you know, there is so-called Hungarian notation, which is a substitute, and many people misunderstand this Hungarian notation, and instead they put pointer as part of the variable name, but it's completely not needed. It is because pointer is a special type in C and it is being checked. So it was never intention of Hungarian notation. Instead, things like those, if it's kilometers or it's miles, can be put as part of the variable name. It will not be checked by the compiler, but at least it will give some idea to people who are looking at the code. Now, another thing. Let's talk now about what could be different types or different cases of value translation. Now we learned only a very simple type of value translation when it's multiplication by number or division by number. And this is the first and most simple type of value translation. Let's call it analytical function translation. Analytical function translation is the case where one value can be translated to another value by using some analytical function, meaning function that's known by the language, and so it is easy to take this algorithm and translate it. We will be dealing also with one-way translation. One-way translation. Versus bidirectional translation. One-way translation is relevant when we can translate one value into another value, but we cannot, with the precision, translate with certainty, translate from the resulting value back to this value. So when we have bidirectional translation, this means that the function that does translation, if it's functional translation, it is monotonic. If the translation is monotonic, then we can translate it back. If it's not, then we cannot do it. So we have, therefore, one-way translation, for example, is a hash function. Hash function is usually just one-way translation, so we get the source value and we translate it usually with a smaller size resultant value. And this is one-way translation. Bidirectional translation is obviously this mile to kilometers and back is bidirectional. And then we have another type of translation that is mapping translation. Mapping translation is usually when we don't have an analytical function that translates one value into another value, but we just use correspondence of resultant numbers. And usually it's just a lookup table. And in this lookup table or some other way that we just know correspondence of each possible source value to the destination value. When we record this translation as a table, so that for each value, source value, we have another value, that's called mapping translation. And that is basically all kinds of translation that we can talk about today. So this concludes our lesson 3. Thank you.